Hey, what's up YouTube? Welcome to another Moralis blueprint. Today we are going to build a fully functional, decentralized autonomous organization from scratch. At the end we are going to have this beautiful frontend on which you can connect your MetaMask, get information straightforward from the DAO and the governance token, and we are going to go through all the process of understanding the technicalities to a DAO. We are going to see how to govern another contract, how to get funding in order to be able to participate on the DAO, how to create new proposals. We are going to learn how to participate on the proposals through the voting process, and of course know how to execute that proposal once the voting process has finished, creating meaningful changes on the government contract. To accomplish that, we are going to build all the smart contracts from scratch, one by one. We are going to use Moralis API endpoints to get information out of the blockchain and connect it to a backend built on Django. And finally, we are going to build a fully functional frontend with a lot of components and a lot of functionalities. And I mean it, a lot of functionalities. But wait a second. What is a DAO to begin with? What is the philosophy behind a DAO? And why DAOs are changing the way we understand organizations as a whole? What's up YouTube, my name is Vasily, your Web3 instructor from Latin America, Ecuador. I've been building on the space since 2020 with cool crypto projects. In my free time I really enjoy singing and playing the guitar, and if the time is good, I like to go out and take some meditations. But enough about me, let's go back to the video and start building. So, autonomous decentralized organizations are organizations which are autonomous and decentralized. And yes, I know, that's not a good enough explanation. So let's dive into it. Let's think about a traditional organization. Let's suppose a bank. In the bank, the people which make the decisions of what happens inside the bank are just the people in charge. It means the owners of the bank and let's say the CEO and the high responsibles of that bank. That make the bank a centralized organization on which all the decisions are driven by the owners. On a decentralized approach, people which owns an account on that bank will have the voting power to decide what happens next on that bank. Think about it as the same traditional approach people has, let's say for example, on the voting system on any democratic country. People have a voting power to decide which is going to be the next governor or the next president. So at the end, a decentralized organization means that anyone which is member of that organization or a country can vote to decide what happens next. But what about autonomous? Well, in a DAO, autonomous means that the decisions can be made without human interaction. And that might sound strange, but it's because are code driven. It means we have smart contracts on which we have the set of rules, all the things we want to happen next, and the execution of the functions of that smart contract will happen automatically once the voting process has finished. So you don't need an actual human to execute the proposal. Okay, maybe you need the human to execute the transaction in order to execute the proposal, but the logic inside the function you want to execute through the voting process is going to be executed automatically. And no matter who executes that function, the person will not be able to change the logic inside of it. So summarizing, a decentralized autonomous organization, or a DAO, is an organization on which the decisions are not made by a centralized authority, let's say a CEO or the owner of a company, but instead the decisions are made by all the members of the organization. And we have several different approaches to that. The first and most common is to use a ERC20 token or NFT token to decide who can vote or who cannot. If you want to be a part of a decentralized organization, you just have to buy the tokens of that organization, and once you have it into your wallet, now you are a part of that organization and you can vote on the next proposal. This approach is not perfect though, because you can literally buy voting power. Because the more tokens you have, the more voting power you will have inside the organization. It means that wealthy people can just buy most of the tokens and make decisions that might not be the best for the interest of the DAO. And even worse, the person who bought a lot of tokens can participate on a vote process, then sell all their tokens and leave the DAO with almost any consequence. And you might be thinking, why do we need a DAO like that at the first place? Well, they have its use cases on certain scenarios. You can think on the worst case scenario when people buy tokens to make wrong decisions, but also it's also common that people which actually owns most of the tokens of an organization wants that organization to succeed. Let's say you are a big investor on a company such as Apple, Google, or any traditional Web 2 company. You will want that company to succeed because you want to preserve your tokens. So this approach is really correct for those type of organizations on which the decisions are really important. And yes, maybe you can have a lot more voting power than other person, but this would mean that the more voting power you have, the more you want the organization to succeed. And this type of approach is the one we are going to teach you on today's blueprint. We are going to create a governance token to decide who can and who cannot vote, a contract to be governed. It means the contract we want to execute a specific function, and all the DAO based on another smart contract, which is going to be the governance contract. But I don't want to leave the explanation as it is, because there are different approaches about how to create a DAO. There is another approach which was proposed by Vitalik Buterin, and it's called skin in the game, which actually literally means you have to put your skin on the game, because if things go wrong, you are going to be penalized. The way this works is that when a voting process has started, you, as the voter, put your voting as collateral. So, at the end, if the voting process finishes and your decision leads to a bad outcome for the organization, well, you will be punished and you will say goodbye to all your funds, or at least the ones you use for the voting. This is also not perfect because things like good and evil, goodness and badness, or what is fundamentally wrong for an organization is something that is still biased by our perceptions as human beings and is not going to be the same on any organization. One of the most common approaches to solve this is that you can just have a set of rules the potential users of your DAO are going to sign before joining, and then you have all the rules on which you explicitly define which is good and which is bad. And finally, we have a different approach, which is my personal favorite, which is called proof of personhood, on which you have to actually demonstrate that you are a human in order to vote. So if you have an organization, no matter if a person has 20,000 tokens and you have just one token, you and that person will have the same voting power, because you are not measuring the voting power on the amount of tokens you have, but just from being part of that. But this is also the hardest to prove, because we have two main problems here. The first one is that there are a lot of bots, and I can just create 100 wallet addresses with one token on each one of them, and now I have 100 votes, which is not fair. So we need a proof to demonstrate that one wallet is actually one person. And the second problem is a little bit more philosophical, but Aristoteles already said it on the Greek era. You couldn't give the command of a boat to a person which has never sailed before. You will prefer that the specialists take command of the boat. And the same happens here on this approach, because maybe a person with just one vote will not have on their mind the best interest of the DAO, will not even understand what are the consequences of their vote, and maybe just vote for fun. And people which is actually interested on the success of the DAO, which actually understands how the DAO works inside, well, they are going to have the exact same voting power. That's why if you're creating your own DAO, as we are doing today, please be sure to choose the correct approach depending on your use case. Now, there are two different voting systems, on-chain voting and off-chain voting. We are going to focus all our attention today on on-chain voting. And the reason is because off-chain voting is not that worth it nowadays. Yes, you might say, okay, if we are working on the blockchain and we know all the advantages of the blockchain, such as immutability, such as security, and etc., why do we ever want to have off-chain voting? Well, the reason was simple. Years before, the gas cost to make a simple transaction, they say on the Ethereum mainnet, were really expensive. And maybe if each vote on your organization cost, let's say $50 or $100, and you need, let's say, 100 votes, well, you will spending $50,000 to $100 just on the voting process. So one of the solutions people came with is to use something like IPFS, register all the votes in IPFS, and then just create one single transaction which is going to be stored on the blockchain. But of course, this is a tricky solution because if you don't have a decentralized oracle to verify the votes actually exist, well, you will end up with another centralized organization which lives on the blockchain but is still centralized. But fortunately, when Ethereum changed from proof of work to proof of stake, the gas costs are now really cheap, and we now also have a lot more blockchains on which each transaction goes like 0.00005 cents. So you don't need to worry anymore about how expensive the voting process would be. And now, just to finish the explanation, let's talk about the last two important topics. First of all, why DAOs are important? Well, first of all, because you are giving back the power to people. If you have a decentralized autonomous organization, no matter the approach you take, it's going to be more transparent because all the votes are going to be stored on the blockchain, and as the blockchain is public, you will know that there is not going to be any kind of manipulation of the voting. And also you are giving the opportunity to the people to actually make decisions of what happens on the organizations they have decided to participate on. And also I must say that the decentralized autonomous organizations has a big disadvantage, and it's because they cannot evolve. This means that maybe today your organization has some kind of needs and you need to make certain types of decision, aka execute as a specific function on a smart contract, but maybe 1, 2, 3 years from now, the needs and the philosophy of your organization will change and you will need to execute different functions, to make different things. And as the blockchain is immutable, once you have deployed the code to the blockchain, you will not be able to change it ever. Fortunately, there is an approach using upgradable smart contracts to solve that, but that will make the DAO really more complicated. However, if you want to know what upgradable contracts are and you want another blueprint talking exclusively about upgradable smart contracts, please let us know and we will work on a video on that matter. Just before we start coding, remember something. We trust the smart contracts, we trust the blockchain, and we trust that the functions are going to execute it by the code. But remember, the code is made by humans, which means that it's not going to be perfect. And if you don't want to have a serious problem in your organization, always remember to make an exhaustive audit to your smart contracts before deploying to a livenet. With that said, we are ready to start creating our DAO. So take a cup of coffee, make yourself comfortable, and get ready your Visual Studio Code because we finally reached the coding part. Let's get started with smart contracts. Please check out the link on the description on which you are going to find the template we are going to use for this project, including the backend, the template for the frontend, and of course the smart contracts, which for now are empty. For this project, we are using Brownie as our Python development framework for smart contracts, but remember that you can use any other framework you want. Maybe you want to deploy this on Remix or using Hardhat. At the end, the smart contracts are going to be the same, so we can continue. If you haven't used Brownie before ever, don't worry because we are going to just cover the really basics of the framework, so you can adapt this to any other framework you would like to. So the first contract we are going to code is the contract which is going to be governed. It means the contract which is going to execute the functions we want. As this is an example, we are going to create a really simple contract called box.sol. Let's start by setting up the license. the Solidity version, and we are also going to import from OpenZeppelin ownable.sol to make this contract be able to use only owner functions. The GitHub Copilot is really good and is trying to autocomplete me the whole contract, but let's just explain the basics of it. First, we're going to need a private variable called value. As good practice, let's add also an event when that value changes. Then we need to have a function to store the value. So function store, it receives a new value, which is going to be a public but only owner. That's why we set up this as only owner. And it's going to set up this value to the input parameter. And lastly, we just need a function to retrieve that value. And you might be thinking, why don't we use a complex smart contract? Well, remember, this is for showcasing purposes. And remember, the point here is for you to understand how the DAO workflow works. So for learning purposes, let's keep it as simple as we can. And that's it. We have our first contract done. Then we need the governance token. Remember, I told you people which has the ownership of a certain token, it could be a ERC20 or a NFT contract, will be able to vote on the DAO. So we need to create that token. We are going to keep using the OpenZeppelin standard for smart contracts. So as always, let's set up the license over here. And generally, we will use something like this. Just import the OpenZeppelin ERC20 token standard. But remember, we want this to be used as the allowance to vote or not into a DAO. So instead of importing this exact import, let's import from extensions ERC20 boasts. These extensions will give our contract the capabilities to be used into a DAO. Again, let's set up the Solidity version 0.8.7 and let's declare the contract. Contract governance token is a ERC20 votes. Let's save this, and this is going to mark this as an error because we need to make some function implementation required by Solidity, some overrides. Let's do that. First, let's declare an event called token transferred, just to know when a new token is transferred, and also some events to know when a token has been burned and when a token has been minted. We are not going to use these events on this tutorial, but it's a good practice to have them. Usually when you are creating an ERC20 token, you will like the new users to buy the token from a market at the current token value, but as this is an example, we are going to let everyone to get some free tokens. So first, let's say uint 256 constant tokens per user, and we are going to allow each user to get like 1000 tokens for free. Let's also set up the max supply for this. So let's say uint 256 constant total supply is going to be equal to 1 million. But remember, we are using Solidity and the ERC20 tokens has 18 decimals. So let's multiply this by 10 and elevate this to 18. Nice. As I told you, we want the users to be able to freely get tokens, but let's allow these once. So for that, we are going to have a mapping from an address to a boolean, and let's say public as claimed tokens. And also for simplicity, let's create an array of addresses on which we are going to store all the holders. Remember, if an address is a holder of this ERC20 token, it means the address will be able to vote on the system. So here we are going to store all the addresses for the token holders. We are going to read information of the holders directly from the blockchain using the frontend, and we are going to use Moralis to get the balance of the wallet on this specific smart contract. And talking about Moralis, if you're working with a big NFT collection or marketplace, step up your blockchain game with Moralis Pro. With twice the computing power and more requests, you can handle even the most demanding projects. Plus, enjoy unlimited daily records on your streams with automatic retries for a seamless experience. And with more replays and longer retention for your historic streams, you'll never miss a beat. Don't settle for basic, upgrade to Moralis Pro today and take your projects to the next level. With that, we now can create a constructor. So constructor uint256, we are going to set a keep percentage. The reason for that is when you are creating a new ERC20 token, is a common practice to mint the total supply to the message.sender. It means the owner of the contract, but we are going to just keep a certain amount of the token and return the rest to the contract in order for other users to freely be able to receive that token. So first of all, we need to declare the ERC20 token over here. This is going to be called Moralis token. The initials are going to be MRST. And remember we are importing from this extension ERC20 votes. So we need to also add a permit. So ERC20 permit of the Moralis token. Let's save this. Now let's open the constructor and let's say uint 256 keep amount is going to be equal to the total supply in multiplication to the keep percentage divided by 100. Let's mint to the message.sender the total supply, and let's transfer back to the contract the total supply less the keep amount. So at the end, we are going to mint all the total supply to the message.sender. It means the contract owner. And then we are going to return to the contract, again, the total supply, but keeping the amount we want for the user. And of course, the contract minter is going to be a new holder. Let's add that user to the array of holders. Let's save this. And with that, we already have all we need in order to use this contract. Now, let's create a function to allow the users to claim the tokens. The function is going to be claim tokens. It's going to be an external function. It's going to require that the user which is claiming the funds is not already on the mapping claim tokens. Remember, we created that one over here, because once a user claims the tokens, it's going to be added to this mapping. So first we need to be sure that the user haven't required tokens before. Now we are going to add the user to that mapping. Then we are going to transfer from the contract to the message.sender the tokens per user. We already know this is going to be just 1000, and we are going to use some math to transform this into ERC20 token, which you already know has 18 decimals. And remember, if a new user claims the tokens, well, it's going to be added to the holders of this ERC20 tokens. So we need to add the user also to the holders array. Let's create now a getter on which we are just going to return the length of the holders, because we want to know how many holders this contract has. And then we need to add some overrides required from Solidity, which I'm not going to get deep into because are like just standard stuff. You can just check this out on the code repo, because I'm going to just copy and paste those, such as what happened when we mint the token, when we burn the token, and what happens after the token has been transferred. And by the way, if you are wondering why we need to use the ERC20 votes at the end, is because this ERC20 votes has this ERC20 permit, which is going to create a snapshot, because we don't want a person to buy a ton of tokens and then dump after the voting is over. This ERC20 permit is going to prevent that here on the after token transfer, because we are going to check that ERC20 votes, so we are always know which person or which address has what amount of tokens on each block. Nice. Now I just added some comments here in order for you to check the code afterwards, and that's it. We already have the contract to be governed, the governance token. It means the ERC20 to know which wallet is going to be able to vote or not. And now we need to create the actual DAO. So now we have this Moralis governor.sol empty contract. We can try to create all the contract by ourselves and try to decide all the rules we are going to need in order for users to vote, to know if a proposal is active or not. But we want to use the latest contract standards, right? And OpenZeppelin provide those. Fortunately, we can cheat on this. Yes, we can go to the docs.openzeppelin.com contracts and use the wizard. This wizard is the easiest way for us to generate a ERC20 token, a NFT token with some parameters which are going to be added automatically, but the one we want the most is the one over here called governor. This governor is going to use the latest standards on the industry to create a DAO with all the functions we need. Let's explain it one by one. So first of all, we need to name the contract, of course, which is going to be Moralis governor. The voting delay is the time since the proposal is created and the voting starts. All of these are measured in block, not in actual time. And here we're going to decide the voting period. It means the time the user has to vote into a proposal. It's common for a DAO to have long voting periods in order to let all the users to vote on a proposal, but as we are using this as a tutorial, let's change this to 1 hour, which is going to be 300 blocks approximately. Remember, this is estimating that one block is 12 seconds, so this is going to be around 1 hour. Maybe a little bit more, maybe a little bit less. We are going to change this later to be just to 10 minutes in order to be able to code this project. The proposal threshold is the minimum amount of votes an account must have in order to be able to vote. Here we can determine that maybe just the users with a lot of votes can vote on a proposal, but we are going to leave this as 0 to let anyone vote on a new proposal. The quorum is about the 4%. It means which is the minimum amount on number of votes of the percentage of votes in order to decide if a proposal goes through or not. The updatable settings, this means this contract is going to have the option for you to upload the voting settings such as the delay, the period, the proposal threshold, and etc. Bravo compatible is if you are going to use a compound compatible contract. Here we are going to decide if we are using an ERC20 token or an ERC721 token to go through the voting system. As we created an ERC20, let's keep this one. And then we need the time controller. The time controller is just to set up all the timing of the smart contract and the roles, such as which is going to be able to execute the contract, which is going to be able to propose a new proposal, etc. Then we have the upgradability section. This is for the upgradable smart contracts we talked about earlier, but as I told you, if we add this, the contract is going to be more and more complex, so we are not going to use this for now. Remember, if you want a specialized video on upgradable smart contracts, please let us know. And with all of that, we have this big smart contract with all the functions we actually need to create a governor. So let's copy this into the clipboard and paste it over here. And as easy as that, we have a governor. And you might be thinking, okay, this feels like cheating. Well, it's like cheating because as simple as that, we have a governor which has all the standards on the industry nowadays. But don't worry, I'm going to explain what is happening over here. As you can see here, this contract imports from a lot more of other contracts. But at the end, remember the basis of a DAO. We can create a new proposal on which we are going to call, which is going to be the function we want to execute on another contract. We can execute the proposal if the voting was successfully. We can cancel the proposal. This cancel function only can be executed before the voting delay. As we set up the voting delay to 1 block, we are not going to actually be able to cancel the proposal, but the contract has it. We have functions just to get to know which is the executor and things like that. But at the end, all what contract is to give us the ability to propose, vote, and execute a proposal into our DAO. Of course, we have something like this called governor settings, on which we are going to set up the voting delay, the voting period, and etc. Also look at the constructor on which we are setting up the token we are going to use as the governance token. Here we are going to send the ERC20 token we just created, and the time lock controller is the one I already told you, which is going to determine the timing for the voting process and also the roles for the DAO, such as the executor, the voters, etc, etc. And the governor settings has here the voting delay, the voting period, and also the minimum amount of votes an account needs to be able to vote. But let's modify these settings in order for us to decide which are going to be these parameters when we deploy the contract. So let's create a new uint called voting delay and another for the voting period and replace those over here. Voting delay and the voting period. Remember, 300 blocks is around 1 hour. Also, we set up the quorum percentage as 4%, but maybe we will want to have more or less percentage in order to execute a proposal. So let's also create a new uint to decide that quorum percentage is going to be. So let's put over here that quorum percentage and replace it over here. So now we can decide all these parameters programmatically when we are deploying this contract. Also, as we want to read some information about this DAO from the front end, let's create a variable over here, which we are going to use later on the video. Let's say uint 256 public s proposal count, and let's set up that value at 0 when we deploy the contract. Again, this contract has a lot of overrides required by Solidity, the same as we did on the governance token. We don't have to touch this at all because they are just standard stuff for Solidity. I just want to add a function at the end to get the proposal count. As we know now, it's going to start at 0. So the last change I'm going to make here is to add 1 to the proposal count every time we generate a new proposal. This is not needed for the DAO itself, but is needed for us to be able to get this information from the frontend when we are creating the web page. And as easy as that, we have a governance contract. Remember, these governance tokens require a ERC20 token we already have, and now we need to create the time lock contract. So let's do that. I just added some comments over here for you in order to be able to understand what is happening on each step. And by the way, if you feel I'm going too fast through how this contract works, don't worry, because I'm going to present you a little bit later on the video a diagram explaining how the workflow on the DAO is. But remember, you can go always to GitHub, OpenZeppelin, and check out the extension for each one of those contracts. So if you want to deeply understand what each contract does, well, you can check those out one by one. So the last smart contract for us is going to be the time lock. Let's set up the basics over here, the license, the version of Solidity, and also we are going to again use OpenZeppelin standard time lock controller. So let's say contract time lock is time lock controller. Again, we are going to have to make some implementations over here, but let's check something. This time lock controller is going to help us to set up the following. First, the mean delay, which is the minimum time that needs to pass before a proposal can be executed. The proposers, remember I said that this contract is going to set up the roles, like the proposers, also the executors, and also the admin. This admin role must be renounced once the contract is deployed in order for the admin to be the actual DAO and not a specific wallet address. Let's create over here the constructor, which is going to receive a uint 256 of the mean delay, an array of addresses, which is going to determine who can make new proposals, an array of executors, the accounts which are going to be able to use that execute function, and also the address of the admin. Let's use the time lock controller constructor and send over all those parameters. And that's it. This is all we need for this time lock controller. This time lock controller is going to be the owner of the box contract.sol, and we use a time lock because we want to wait until a new bot can be executed. Also, the time lock controller gives us the opportunity to get out if we don't like a proposal. And look at this, as easy as that, we have our complete DAO. We have the contract to be governed, the governance token, the DAO itself using the latest cutting edge standards of the industry, and also a time node which is going to manage that DAO. And by the way, if you want to know how the roles work, well, we have an admin role, proposer role, executor role, and canceller role. These roles are really important because we are going to set up these roles when deploying the smart contract. And as we already have these contracts, let's deploy them, shall we? For deploying this contract, I already have some utility scripts you are going to find on the template, such as these helpful scripts Python script, on which we are going to have a way to just get information of the account, encode the function data. This is the function we are going to use to encode the function we want to execute on the governed contract. In this case, we know that it's going to be this store function. And also we have a way to send the build information to the front end, because we are going to need, as you already might know, the contract API and the contract address in order to interact to a contract. With that said, we can start using this on this deploy contracts.py, which is now empty. First, let's get started importing all we are going to need, which is going to be the Moralis governor, the time lock, the box contract, and the governance token. Also, we are going to use network and config from Brownie. We are going to also need that get account from the help of the scripts I just showed you. And we are going to also use web3. So from web3, import web3. Remember that in order to use Brownie and web3, you must install those using pip with pip install web3 and pip install it Brownie. Let's set up here the parameters we are going to use on the constructor or the DAO, starting by the quorum percentage. We are going to keep this as 4, as OpenZeppelin originally does, but remember you can use any number over here. Let's say the voting period to just 50 blocks, and remember this is because if 300 blocks equals to 1 hour, it means that 50 blocks is around 10 minutes. Let's say the voting delay to 1 block, and let's also create the variables from the time lock. We are going to say that the mean delay is going to be 5 blocks, the mean delay is going to be 5 seconds. And remember, we said that we want anyone to be able to execute and make proposals. We are going to set up, which we are going to use for set up those roles. If we set up a zero address, it means the smart contract is going to understand that anyone can use that functions. So let's create a main function, def main. It's going to pass by now. And up here, let's say def deploy contracts. We are going to set the account as that get account function. By the way, that get account function is just going to take the account based on the context, if we are on a local environment or if we want to use an actual private key. Let's first start by deploying the governance token. So governance token equals to governance token.deploy from account. And remember, our constructor requires us to define which is the percentage we want to keep after the contract is deployed. So I'm going to say that I want to keep the 5%. And also is a good practice to verify the contracts. So we are going to let the autocomplete to work, publisher, config networks.show-active, get verify. It means that this is going to check here on this Brownie config, which I already set it up for you, if the contract must be verified or not. As we are going to deploy this on the Guardi network, I actually want this contract to be verified. And that's it for the governance token. Let's delegate that governance token to our account. So governance token.delegate to the account, and we also need to know which is signing this transaction, which is going to be the same account. Now we can check the number of checkpoints. So print f number of checkpoints, going to be governance token dot num of checkpoints of the account, of course. And if you are wondering what does it mean that we are using this delegate function and also that num of checkpoints, is because this extension, well, keeps the history of the checkpoints of each account's both power. Both power can be delegated either by calling the delegate function directly or by providing a signature. So we are using the functions of the ERC 20 votes.sol in order to delegate that voting power. And this is because by default, token balance does not account for voting power. This makes transfers cheaper. The downside is that it requires the users to delegate themselves in order to activate checkpoints and have the voting power tracked. So basically, even though we are going to have the 20% of the tokens at first, we are not going to be able to actually vote on the DAO. So using this delegate to ourselves, in this case, to the account, then we are going to be able to participate as a voter. Let's continue. Now let's deploy that time lock contract. So governance time lock is going to be equal to timelock.deploy. And here we need to send those constructor parameters, starting with the mean delay, as we don't want to have just a certain amount of executors and voters. We are going to send two empty arrays over here. Remember, this is because the time lock requires to send an array of the proposers and the executors. And if we send over these empty arrays, well, we are saying that we don't have any preference on which can or cannot propose or execute a proposal. As always, we need to sign this using from account, and I want also to verify this contract if we are deploying this into the Goerli network. So let's just make a print statement over here and say f governance time lock is deployed on this address. Now, as we have the governance token and the governance time lock, we can deploy the actual DAO, which, as you already know, requires those contracts as input parameters over here. So let's say governor going to be equal to Moralis governor.deploy. And we need to set that information. First of all, the governance token.address, the governance timelock.address, the quorum percentage, the voting period, and the voting delay. That again we set up as 4% for the quorum percentage. The voting period is going to be around 10 minutes, and the voting delay is going to be just 1. Again, let's sign this using our account, and let's verify this if we are on a live network. Now, once we have deployed these contracts, we need to set up the roles. The roles we already talked about over here, which you know is going to be the proposer, the executor, the canceller role, and etc. So let's say proposer role is going to be equal to the governance timelock dot proposer role. Or the same goes for the executor role, and the same goes for the admin role. So now we can say governance timelock dot grant role, and we are going to give the proposer role to the governor because we want the governor to be able to propose. We are going to sign this using our always trusted from account. Now we need the executor role, but instead of just letting the contract to be the executor, let's use here that hero address we set up earlier, because as I told you, we are going to let anyone to execute that proposals. And let's set the admin role. In this case, it's going to be the account. The account which is deploying this is going to be the admin of this. And remember, this admin role is not the admin role of the governance itself, but is the admin role of the time lock contract. And as I told you, in order to make this more democratic, this admin role should be renounced afterwards. And now, finally, we need to deploy the contract to be governed. In this case, we know this box contract is a really simple smart contract, so we don't have to do anything besides just maybe adding that verifying functionality. And let's create a transaction on which we are going to say box.transfer ownership, because remember, we want the owner of this contract not to be the user, but actually the time lock. So transfer ownership, and the owner is going to be the time lock. We are going to get the time lock on the index -1. It means it's going to take the last implementation of the time lock from account. And let's put a tx.wait over here. And here, instead of just passing, let's actually use that deploy contracts function. So yeah, at the end, this is all we need to deploy the contracts. We are deploying the governance token with its constructor parameters, the governance time lock set up in the mean delay, the roles, the governor, which needs both of those contracts, and also the other input parameters for the constructor. Then we use the time lock to set up the roles for the proposer, the executor, and also the admin. Remember, ideally these admin roles should be renounced afterwards. And then we deploy the box contract and we transfer the ownership to the time lock. And as you already know, this time lock is the contract which is actually managing the whole DAO. Let's check if this works properly. So let's go to the terminal and say Brownie run scripts deploy contracts, but for now let's just deploy on the local network. Okay, everything worked properly. It means that we know that we can deploy all the contracts and also give all the roles we need. To understand better how this works, let's check out these diagrams. First of all, we need to deploy the governance token and the time lock because they are both requirements of the governance contract. This governance contract is going to be the one who handles the proposals, the voting, and the execution of the DAO. The voting process is going to be related to a governing contract, in our case, the box contract. Here are the functions we want to execute and the ones we are going to discuss through the voting process. Once this governing contract is deployed, the ownership is transferred to the time lock, because the time lock is the one responsible to set up the roles, and at the end, the time lock is the one which is going to control the governance contract. So the basic workflow of a voting process is going to be like this. First of all, we need to deploy the contracts, set up the rules, transfer the ownership of the contract. We need to generate a new proposal. We are going to go through the voting process, which is going to depend on the voting period. If the voting process does not succeed, well, the voting process is going to end and that proposal is going to be discarded. But if the voting process succeeds, well, that proposal is going to be queued. The reason we queue the proposal is because we might have more than one proposal. And after we queue the proposal, we can execute it. The execution means we are going to execute the function of the governing contract. So now we have this cool script to deploy all the contracts. You may be wondering, how do we know this works? How do we know that the voting process you just described actually works? Well, I'm going to leave you another script called deployed and execute, on which we are going to go through all that process. I'm not going to enter to detail how this script works because we are going to go through all the process of the voting system when we code the frontend. However, if you just want to know if this script works for all the workflow, you can just run it using Brownie run scripts, deploy, and execute. And this is going to have a lot of transactions over here. And as you can see here, we have a lot of transactions over here. And the reason is, remember, we have a voting period. So we are just using this script to simulate a lot of blocks has been passed until the whole process has finished. And as you can see at the end over here, the box contract started with a value of 0, which is the default for you into 56, and after all the voting process, the value has changed into 150. It means the proposal went through correctly and the voting system works. Again, don't worry if you don't understand how this script actually works, because we are going through all the voting process when we are creating the frontend. So to finish this section of the tutorial, let's just deploy that contract into an actual network. So let's use Brownie run scripts, deploy contracts, and let's use the network go early. Now, as we are deploying this into a live network, don't forget you have to add your keys into your .env file over here. You need to provide your Infura project ID. This is because Brownie works by default with Infura. You need to provide your private key, your etherscan token. This is to verify automatically the contracts. Again, if you don't have one, you just can go to etherscan.io create your account, and under API keys, you can generate new API keys to verify your contracts. So once you have all of this set it up, we can now run this deploy contracts script. Let's hit on enter. And as we are running this into a live network, well, let's just wait until all of this finishes. Once the process is finished, you will have a map on which you are going to have all the information of the deployed contracts. As you can see here, I've been doing some testing to deploy different versions of the contracts, so that's why I have 3 addresses for each one of those, but you will have just one of them. So now, if you are using the template we are using for this project, it's important for you to execute this update frontend for the wireless network, because this script is going to send the information to the frontend folder on which we are going to get that information as a JSON, including the APIs for all the contracts, and as I already showed you, the map of the addresses we are going to use for this case. With that said, we already finished all the part of the smart contracts. If you just wanted to learn how to code a DAO using Solidity, that's it. You can leave this video now. Don't forget to give us a like and leave a comment telling us which other blueprint you would like to see next. Because now, after we deployed all this, we are ready to start building the frontend functionality. Let's get started with the frontend. So, please, if you are using the template I left you in the description, you are going to have the frontend folder, and also you should already have the chain info folder with the information of your deployed contracts. So the first step for us is to install all the dependencies we are going to need for this project. We just type in yarn and let's wait until this gets installed. I also have to mention that for this part of the video, I'm going to assume you already know how to use front-end frameworks such as React, and I'm going just to explain the most important parts, just to don't make this video that longer. Once you have all the dependencies, we can just run npm start, and this will execute the application on the local host. You will have a template like this one. It's the same one I showed you at the beginning of the video, but if you click on any button, you are not going to have any functionality, and if you go through the tabs, well, these tabs are not going to give you any response at all. So we are going to code all the functionality we need to connect our wallet, get the live information out of the blockchain, and then go all through the voting process. So let's get started with connecting our wallet. In order to get all this information, we firstly need to have a wallet connected. In this case, I'm using MetaMask. So let's get started with that. Here on the components, we have a component called header, on which we have here all the information for the connecting button, including, the navbar, the top navbar, and so on. The most important part here is this onClink function on the button, which for now is empty. We are going to create a function over here in order to connect to MetaMask. So please go to the Web3 section, and you are going to have a file named connectwallet.js, which already has some basic imports from ethers and from React itself. As we are using this on different files, we are going to create a React hook for this connect function. So I'm going to say export function use MetaMask state. Let's open the curly brackets here, and here we are going to use the functionality to connect to MetaMask. So first, let's declare some important variables, as we have over here, account, signer, and is connected, which are required by ethereum.js. And let's create a new async function called connect to MetaMask. In this connect to MetaMask, we are going to use ethereum.js to go through the connecting process. So first, we need to declare a provider. The provider is going to take the window.ethereum because we know that MetaMask works with that window. Then we need to get the accounts from the add request accounts functionality. This is going to take all the accounts on that wallet. And then we need to get the signer, the actual account which is going to sign the transactions, and we are going to take the account in the index number 0, which is going to be the one is going to be activated when we sign the singing transaction. Then we just have to update the variables we have here, such as the account signer and is connected. And of course, let's make some error handling over here in order to know if something went wrong. So I'm going to grab all this function in a try statement and say here catch the error, and let's console.log the error if something goes wrong. And as this is a hook, well, we need to return those things. So return is connected, account signer, and connect to MetaMask. And as easy as that, we have already a function we can use to sign over. Now, traditionally, we could just use this hook directly on the header, but as we are going to use this signer, account, and is connected states through all the application, we should import this on our main app.js. So as you can see here, I already have that import commented. So let's just remove that comment. And we are going to use that use MetaMask state from the connect wallet. Once we have that, we can declare that functions. So we can copy this and paste it over here. We are going to use all the functionalities is connected account signer and the function connect to MetaMask going to be equal to use MetaMask state. And then we can pass these parameters to the header. So connect to MetaMask is going to be equal to connect to MetaMask. And the same goes by for the other parameters. Now we can save this. And I just made a typo here because it's MetaMask state. So if we save over here this, we are going to have this over. That means that now we can go back to the header. And as you can see here, I already set it up on the template, these parameters as inputs. So we can use that to connect to MetaMask. So let's do it. Over here, we are going to use this isConnected function to verify if the wallet is already connected. If so, we are just going to disable the button and say that we are already connected. Otherwise, we need to execute a function. The function we actually need to use is the one we just created. We already know it's called connect to MetaMask. Once we save this, we can return to our web page, click on Connect Wallet, and it's going to say for me that it's already connected, but that is because I already connected before to this wallet. If I disconnect this account and reload the page, if I click Connect Wallet, it's going to trigger my MetaMask. I can click on Next, and now we are connected. As easy as that. Now, as we have this connection, it means we have this signer, the account, and is connected. We can start using that in conjunction with our smart contracts to start executing those functions. So here on the app.js, I need to send these exact same parameters as I did on the header to the navbar and understand the navbar as the component which has all this interface, including these buttons. And the only thing we need here is actually to send the signer, which is going to be, again, the signer. You might notice that here on the header, we didn't even use the account and the signer, but I'm just sending this over because if you want to upgrade the functionality of this application, you can then use all of this with different wallets or in different contexts. With that said, let's continue looking which is the next thing we have to add here. Okay, here we have a proposal card on which we want to show up all the proposals we have for this smart contract. It means we need a function to get the proposals count. And if you remember, on our smart contracts, we have here on the governance the proposal count, which is going to start at 0 and is going to add 1 each time someone creates a proposal. So we need to get this variable over here. And if you remember, we have this get number of proposals function, and this is the exactly one we need to create. So in order to do that, let's go back to the front end. Here on the Web3 files, I have another file called get proposal count, which already have some imports. Here we have the imports for the contract API and the Moralis governor. So uncomment this, and these imports, of course, come from the chain info folder we just sent from the build folder on Brownie. And here we have the contracts, again, Moralis governor, as you can see here. And we have the map of the deployments, which we already know are all of these addresses. We are going to always take the last one, which is going to be the one at the index 0 on each one of those. So to get the proposal count, let's use this as we are getting and creating a new hook. So function use get proposals. We need here another try statement with its corresponding catch for the error. Let's console.log that error. And here we can put the information we need. And as we already did before, we need here a provider. The provider is going to be the Ethereum window. We need a contract because always when we want to interact with a contract, we need the contract address, the contract API, and a signer. So let's take the contract address from the map.json. Let's take the contract API from the contract API we just imported over here. So contract API equals to contract.api. Now we have to declare an instance of that token. So let's say governance contract is going to be equal to new ethers contract, and we are going to pass out the contract, the API, and the provider. We actually don't need a signer in this case because these are read-only functions, so we don't have to sign the transaction. That's why we declare a provider and not a signer. Now we can say const value is going to be equal to await governance contract. The actual name of the function is get number of proposals. And this is mad at me because this needs an asynchronous function I just forget to create. So let's do that. Async function get proposal count. Let's open this up and let's paste all of the try statement inside that function. And now it's happy with me. And of course we need to return a value. So we are going to also create a state value named proposal count. And we are going to set up that proposal count with the value. But the value comes as a big number from Solidity. So let's also transform this into a string to string. And this is it. We are ready. We have the function to get the proposal counts. Just double check that this function name is the exact same one as we have on the contract. Get number of proposals, and yes, get number of proposals. And as we did on the last hook, we just need to return those values. So I'm going to return the proposal count and the function get proposal count. With that, we can import this on the navbar and use that. So let's do it. So here on the navbar, we can import that get proposals, use get proposals. So let's copy this. Let's say import use get proposals from web3 proposals count, and then we can use that variables. So we can say proposal count and get proposal count. Copy this. Let's say const in brackets. This is going to be equal to use get proposals. Now we can use both this function and the variable. So in order to do that, let's create a use effect to update that parameter the first time we load this page. So use effect going to be equal. Let's keep that opened. And here inside of the function, we are just going to call this get proposal count. This is going to update that information each time we reload the page. And now we just have to take this proposal count and use it down here on the total proposals section. So we can just make this smaller and say proposal count. Let's save this. Let's go back to the page. And as you can see here, we have the number of 1. And again, the reason is because I've been doing testing on this smart contract. So I already made one proposal, which was already added to the smart contract. Nice. Now let's take the total voters. And this process is going to be almost exactly the same. Why? Because if you remember, again, in our smart contract, the governance token, we have these as holders And if we look up for this, we have the function get holder's length, which is also a read-only function, and is going to return the holder's length. If an account is a holder of this smart contract, that means that account can participate on the voting process. So let's do that the exact same way as we did here. So I'm going to go faster this time because we are just doing almost exactly the same, but just changing the contract address we are interacting with. We have another file called get voters count, which is going to return that information exactly. And actually, I'm just going to fill up all that information really fast with a simple copy and paste from what I already have here. Just don't forget to import correctly both the contract address and the contract API, set up the voters, set up a provider. The contract is the governance token. The API is the API. Then we create a new instance of that governance token, and then we call this function get holders length. Again, we can double check that on the governance token get holders length, and the name is the exact same. So we can return the value but into a toString. And as easy as that, we have another functionality ready. Let's use also that on the navbar. So let's take the hook name, use get total voters. Let's copy this, go to the navbar, import it over here, import. This is going to come from get voters count. If run, it is. And then we can take both the variable and the function and declare it in the navbar. So we can do the exact same as we did before. Const, open brackets, use this, just get total voters. And let's create also a hook as we did here in order to update that value the first time we load the page. So use effect, get voters. And now we can just use this voters variable and use it down here. Voters space, save this, go back to the page, reload, and we have the total proposals and the total voters. The number is also 1 because for this smart contract, I'm just using the deployer account and no other accounts. Now we have the voting power. This is going to be more interesting because the voting power is going to depend on the amount of tokens each account has. So we need to get the balance of that token. And for that, we are going to use Moralis. So if you don't have a Moralis account yet, this is the part of the video for you to go to moralis.io, create your account. And here on your admin panel, you are going to get your free API key, which is really good for basic petitions, but we really encourage you to take a look to the pro plans if you're going to manage a lot of workload on your applications. We are going to use the endpoint get ERC20 token balance by wallet, and on which we have to first provide our wallet address. I already pasted over here. The chain, we are using Goerli, which has the code 0x5, and here we have to add the address of the contract we want to check out, in this case our governance token. If you don't know which address this is, don't worry, you can just go to your map.json, and here on your last deployment you are going to have that contract address. So we can copy this, go back to the Moralis endpoint, paste it over here, and if we click on try it, well, this is going to give us the response of the total tokens I have on this wallet for the Moralis token. Of course, we don't want to just use this on the web page. We want to consume this API, and for that, we need to create a backend. But don't worry about that because I already left you the template for the backend as well on the project. So we can return to the Moralis project. Here on the backend folder, you are going to find a file called services.py, which is going to import from the Moralis EVM API. Just don't forget to use pip install Moralis to get access to this. And we are setting up our API key. Your API key is the one you are going to get from your admin panel. And in this case, you should store that on this .m file. Just remember, do not share this with anyone because it's sensitive information. So here on the web page, we can just copy this code, go back to the services.py and paste it over here. The import we already have. the API we already have. So now we can take this and make it part of this function get token balance. And instead of using this bourne address, let's use the address we are going to put as parameter. In this case, this address is going to be the one which comes from MetaMask. The chain is going to be 0xpi. We don't need to specify the block. And again, the token address comes from our deployments. So go to your map.json, take the last deployment of the governance token and paste the address over here. Instead of just printing the result, let's return that result. Let's check if this works. So let's say value is going to be equal to get token balance with this address, but let's double check if the auto-completion is actually getting my address. So let's copy over here, go back to the code and paste it over here. Indeed, it was a different wallet address. And let's print that value. If everything goes well, I can go to my terminal and here on the backend, I can go to the tokens, Python services.py, and this is going to return the information of the balance I have on this specific contract. So now we know this works properly. We can delete this and use this function on a new view. This function is called getTokenBalance. So if we go to views, I already importing this on the template I left you, and we can say the address is going to be equal to requests.get address, and is the only parameter that function is. So I'm going to say the result going to be equal to getTokenBalance, sending that address. And as JavaScript does not understand Python dictionaries, let's transform this into a JSON with json.dumps of that result and return a HTTP response on a JSON format. And this is it for this view. Now we can get the view name, go to URLs and add that URL here as a path. So path getBalance views.getBalance. And as we are using relative path names on the front end, let's also give it a name. Just don't forget to import the views from the project. And this is it for the backend side. With that, we already have a way to connect to the Moralis API and set the information to the frontend each time we connect or we call this getBalance endpoint. So on the terminal, I'm going to run python manage.py run server, and the only thing left I need is on the frontend, go to the package.json and add a proxy pointing to the AP address on which my server is running. So let's connect to that endpoint. Here we have another file called getTokenBalance, which has this actions library. Don't worry, if you install the dependencies of the template, you are going to already have this. So let's connect to that endpoint. Let's create a hook as we did before. Set up a new variable called user balance. There's going to be a user state. And let's declare a new async function called getBalance. Of course, we are going to send here the wallet address as parameter. And let's just connect to that endpoint with Axios. So let's say await axios.get. Let's connect to the endpoint /getBalance. And we are going to send the wallet address, but we have to put here a question mark and say address equals to wallet address. If everything goes well, let's say then we want to do something else with the response. And let's also catch the error if something goes wrong. And yeah, this is it. Now we can make some logic over here. As this is going to return a big number in Solidity format, we need to transform this in something JavaScript will be able to understand. So let's say const balance is going to be res.data 0.balance. I know this is the one we want, basically because if we check the endpoint, is that exact same part. We are going to have an array of elements. We are going to take the first one because we just are using one address to check out, and we want to get the balance. So now let's say const decimals. We know the ERC20 token has 18 decimals. And let's say now const balance in MRST. MRST is the Moralis token. It's going to be equal to ethers.utils.format units, and let's send the balance and the decimals. And finally, let's use that set user balance to put here the balance in Moralis tokens. And of course, we need to return both the variable user balance and the function get balance. And here is without an s, so yeah, that's it. Now we have this hood, which is going to be used to get that balance. The difference here is that we are going to need a wallet address over here. This wallet address over here, of course, depends on the signer. So let's try to use this on the navbar. Same as we did before, let's copy the hook name, go back to the header. Same as we did before, let's copy the hook name, use get balance, go back to the navbar and import that. Now we can get this user balance and get balance, declare it over here. So const is going to be equal to use get balance. And now we can declare a new hook as we did before, but instead of just declaring or using this get balance function, remember this is going to depend on the signer. So if you remember on our app.js, we are sending the signer directly to the navbar, so we can set up that signer over here as a props. So we can use that props now. So that's why we are going to say if we have a signer, well, get me the balance of the signer dot address. And of course, we need to listen each time that signer changes. Finally, we can use this user balance variable and put it over here. So let's save this, go back to the web page. And as you can see here, this already uploaded the value, but let's reload this. This is going to appear as 0 if we click on connect wallet. Well, now we automatically get the information, which is automatically formatted as we decided here using these format units. That's nice. We are half of the way. We have the proposals, the voters, the voting power. Now we need to get the current value. I'm not going to stop to explain how to get the current value because this is going to be, again, talk to the contract box.sol and just use this retrieve function over here. So I'm going to do this really fast. Here I have a function called getCurrentValue. Let's uncomment this, save it over here. Let's create a new hook called useGetValue, which is going to have the box value, the set value, connect to that contract, create a new instance, use the retrieve function and return it as a string on which we are returning the box value and the get value. So now let's, as we just did, copy the hook name, go back to the navbar, import it over here. So import use get value from get current value. Let's declare those variable and function as we did over here. So box value and get value, and this is going to be equal to use get value, we just imported. And now we can use this. In this case, we want to render this on 2 occasions. So instead of get votes, let's call that get value. But we also want to update this each time we click on this current value, because as you can see here, we are going to be changing tabs, and let's also ask to update that each time we click on here on current value. So here in this navigation, besides of just changing the tab, let's also execute that get value function, and we can have 2 different approaches here. We can just leave this as it is, or we can also update this each time the box value changes, because I already doing that each time we change the tab. So now we can just take this box value, go back here and change this value to the box value. Save this, go back to the web page, and as you can see here, the current value of this box is 7. Again, this is because I was already making tests in order to record the trailer for this blueprint. Nice, really nice. Now we need to request funds. This account, as it is the deployer account already has the necessary funds to participate on the DAO, but let's suppose we are going to have a lot more of participants and we need to execute a function in order for them to request and get access to those funds. So let's create a new hook in order to accomplish that. Again, let's go back to Visual Studio Code. We are going to have here another hook, which is going to be called get funds. Again, it has these imports. I'm going to uncomment to get in the contract address and the contract API. And let's create another hook. As you can see here, this process here on the front end is kind of repetitive, but I made this that way for you to be able to follow up. We are just calling the functions on the smart contracts and creating hooks for each one of those. Let's here create an async function request funds, which is going to take, of course, a signer. And here, let's say try with its respective catch statement, the error, and let's console.log the error. So now here on this try statement, we can again set the contract address, set the contract API, set a new instance. The difference here is we are not using a provider, we actually using the signer because this is the actual wallet we want to get funded. We are going to create a new transaction, await governance token dot claim tokens. Let's just verify that that's the function name, claim tokens. That's right. And we are going to set up a gas limit. Let's wait till that transaction goes by, one block. And yep, this is it. Now we can just return this function, return request funds. And with that, we can just call that function on our project. So again, we can just take the hook name, use request funds, go to the navbar, import it over here, declare it as same as the other, const request funds equals to use request funds. And now we can execute this function each time we click on this get funds button over here. So let's do that. Let's go back to that section, get funds. This is for the navigation, but actually here we have that button. So let's change this empty on click to that request funds. I'm using the request funds, but I'm not sending over the actual signer. So let's cut this and let's ask here. So let's send the signer over here. Let's save this. And with this might work properly. So let's return here, reload this, connect wallet. We are again connected to the wallet number 3. Let's click on get funds. This is going to trigger the function this time. Let's confirm, and we should just wait until this transaction goes by. Once the transaction finishes, we go back to the Moralis DAO and reload the page. As you can see here, we already have 2 voters. This gets updated automatically. And if we connect the wallet, well, we are going to have the voting power of this wallet address. I'm just going to change my account from the one I deployed the contract because that is the account on which I have more gas to pay for the transactions. Okay, nice, let's continue. So here on the propose, we have 2 parts. One on which we are going to send the proposal description and the proposal value, and also something on which we are going to have the last proposal. The last proposal is something that is going to be triggered every time we execute that propose function. This propose function has an event on which we are going to have the proposal ID. That proposal ID is really important because we are going to need that proposal ID to know where to vote and also what proposal we want to execute or not. So let's take care of that. As we don't want to overcomplicate this more, we are not going to store that proposal ID into a database, but instead let's use a really cool functionality of JavaScript with the browser, which is the local storage. There we are going to store that information. So I'm just going to copy and paste this really basic hook I created to do so on this use local storage, which is going to use that latest ID, and it's going to have a really generic usage on which we are going to get the latest ID, set the local storage with a key and a value, get the local storage, verify the local storage, remove and clear the local storage, and also get the IDs, which is going to just take that information from the browser local storage. With that said, we can go to the new proposal hook, which is over here. As you can see here, I have these imports. Let's uncomment those. And we have the contract addresses, the box contract API. Remember, the DAO or the governor contract is going to execute functions from this contract, the Moralis governor, of course, and we are going to use that use local storage to store that information on the local storage so we can get it no matter on which tab we are going to be. Okay, let's get started with the new proposal functionality. This is going to be the more complex function by far, but at the end is still going to be something like really simple if we know what we are doing. So let's also say export function use create proposal as a new hook. Let's declare here some important variables such as the proposal description, the value we want to store, and let's use that use local storage functionalities, which is important for the last hook. Nice. Now we want to read once every time we execute this proposal that information from the local storage. It means we want to get the ID. If we already saved some ID on that local storage, that's why we're going to use this use effect. And now let's create an asynchronous functionality. This asynchronous functionality is going to take the signer, the proposal description, and the value as parameters. Inside of this, let's create our try catch statement just for error handling. And inside the try, let's start with the actual process. So first of all, we need to clear the local storage if time we did do this, because we don't want to have accumulated anything rather than the last ID. Now let's say const box contract is going to be the imported contract addresses, but we want to be the box. We need the Moralis governor, of course. It's going to be the exact same, but for the Moralis governor, we need again the box API and the governor API. Now we need to create an instance of the Moralis governor. So const Moralis governor contract instance is going to be new ethers contract, again the same as we did before, you know. And now we need to create an interface of that box contract. So box interface is equal to new ethers utils interface box.api. The reason is because we don't need an instance of the box contract as we need for the governor contract. We just need the interface to understand which functions this box interface has, and we can call that functions using the Moralis governor. Now we need to encode the function into a hash, so we are going to set const encoded function equals to box interface dot encode function data. We know that the function is called store, and we want to set up here a value. That value is going to be the one we are going to propose to be changed. As you know, the value of our contract is 7, so when we create a new proposal with a description and a value, this value is going to be the one which is going to be sent as a proposal, and once the voting process is over, the DAO participants are going to decide if they are going to change or not this value. Now we have to create that proposed transaction, so let's say const proposed transaction equals await Moralis governor contract instance dot propose, and here we need to send some information. I'm going to show you right now. We are sending over the box contract into an array. We are sending here 0. Here is the value. We are not sending any value to this transaction because it's not a payable function. Here we have the encoded function. We are saying that we want to execute this store function over here, and we are sending the proposal description, which we are going to have as input parameter each time we execute this. And of course, we are setting up a gas limit. How do we know which parameters we need to use over here? Well, let's just check again our governance Moralis contract. And here you can see that the propose function requires the targets, in this case, the box contract, the values, we are not sending any value here. Cal datas is the function we want, in this case, the encoded function. And the description is just a string, which is going to be the proposal description. As easy as that. As we have a delay between the proposal is made and the voting process, let's wait until 3 block confirmations each time a new proposal is launched. So propose tx.wait3. Now we can get that proposal ID from the event I told you, which is const proposed ID equals to propose received events, and instead of using the args0, I'm just going to say args and give me the proposal ID. This proposal ID is the one we are going to store on the local storage. But remember, this is going to come as a big number, and JavaScript does not understand that. So let's transform this to const bn value equals to ethers.big number dot from proposal ID. And now let's use all the setters we defined up here. So let's say set proposal to that value, set the value we want to store to the value, set the proposal description to the proposal description. And now let's use that set local storage to store the ID. And as simple as that, we have all the script we need to send over that proposed transaction. Of course, we need to return all those variables and functions of the hook. Create proposal, proposal, the new value, and the proposal description. So, as we did before, we need to use this on our navbar. So, let's take the hook name, use create proposal over here, go to the navbar, import it on the top, import from web3 create proposal, and declare those over here. Now let's take the variables and the function names. Let's copy this, paste it over here, and this is going to be equal to use create proposal. And now we can start using all this information as we did before, with the difference that this is not create proposal, but new proposal instead. So let's save this, and now our frontend is happy with us. So let's change this last proposal to the latest proposal, which we stored. Let's go back to the code and use that. We are going to use this short variable I declared before, short ID, because this is going to return us a really big string of the proposal, and we want to format this to something more readable on the front end. So I'm going to create a new use effect down here, which is going to take that proposal and is going to format it to a better way. And this is going to change each time that proposal also changes. Now we can use this short ID over here on the proposal section. So we can go back to the propose section, which is over here. And here we have this last proposal, which is going to have this short ID. Let's go back to propose, and as you can see here, we get the information of the last proposal. Again, I already have a proposal over here because I already was testing this out. At this point, we already covered the most important parts of this frontend, which is getting the information out of the blockchain and know how to execute the different functions on the smart contracts. So in order to keep repeating myself and just telling we are going to execute this function, create a new hook and import it and use it, I'm going to show you the final product and explain the process of propose, vote, and execute, and how that is related to the actual code. So let's go to that. So regarding to the voting process, we are going to have a vote box, which is going to handle the different stages of the voting process. We have 7 different stages from pending to executed, and it depends into a function called state. We have here another hook called useGetState, on which we are again just calling that Moralis governor and executing the state function. So based on that states, we are going to set up different things. If the voting is active, well, we are going to have 3 buttons to vote in favor, against, or abstain. The voting works like this. 1 is going to be in favor, 0 is going to be against, and 2 is going to be to abstain the voting system. Then we have the execute box, which is going to basically do the same to get the information of which is the state of the proposal. And if the proposal is succeeded, it means a proposal went through, users has voted, and most of the votes are in favor. Well, this means we can then execute that contract. And this is going to also change depending on which is the state of that smart contract. Again, I'm not going to explain one by one these last parts, and the reason is because I already showed you how to get the information out of the blockchain and how to execute the functions. And here we are just executing the functions of that smart contract. So let's go through all the process and see if this works actually properly. So I already have connected my wallet. The current value is 7. We can get the funds. I don't need it because I already have enough to vote. Let's create a proposal. The proposal is going to say, I want to change the value. Instead of 7, let's say 42. Let's create that proposal. This is going to trigger that transaction, and we can wait until that's done. Remember, when we created that new proposal functionality, we said that we are going to wait until 3 block confirmations until the voting process starts. So now we just have to wait until this finishes. We have 1 block confirmation right now, but we have to wait 2 more. In the meantime, if we check the logs, as I told you, we are going to have an event called proposal created, which is going to have this proposal ID, which is the one we are storing on the local storage to use that on the other component. Also, we have more information we might need in other contests, such as the proposer, the address, the values, the call data, the start block, and the end block. Now, if we go to the vote section, this is going to change and is going to let us vote on that proposal. I'm going to vote in favor and say, yes, I want to change. Let's vote in favor. This is going to trigger another transaction. Let's confirm this. Again, let's go back to the block explorer and let's wait until this finishes. This vote has been processed, so this means we have voted in favor. And remember, we need to wait until this proposal is finished. The reason is because, remember, on the smart contracts, we set this up on the deployment to be equal to at least 10 minutes. So we must wait until this proposal has at least 10 minutes from being created. Until that, if we go to the execute function, this is going to tell us that the voting process is still active, so we must wait. I'll see you in 5 minutes. After the voting period has finished, if we go back to the page, this execute part now is going to change, and it says that the vote has succeeded. The reason is because we just have 1 vote in favor, so we can now queue that proposal execution. Let's confirm this. Let's check the transaction. It seems that it went properly, so nice. It's just indexing right now. And if we go back to the execute function, we can just execute now. So let's also execute that function. Let's wait until this transaction also goes by. It seems it also has finished, but it's just indexing. The another one for Q is, of course, a success. And if we go to the current value, now we just have to wait until this transaction finishes the actual execution of the proposal. So let's wait some time. Once the transaction has finished, let's return to the page, and if we click on current value, this value should now tell us that the POX value is 42. So we did it. We go through all the process from creating a proposal, voting, and executing the smart contract, and also getting live information out of the blockchain. And that was it. This was this week blueprint. We learned how to create a whole decentralized autonomous organization from scratch, going through all of the contracts. We created a pretty nice front end with all the functionalities we need so far, and we also connected to the Moralis API through a backend built on Django. I really hope you enjoyed this blueprint so far, and I'll see you on the next occasion. See ya!